Hello. Welcome to JavaScript The Hard Parts V2, which was the front-end master's training I did this half. This is the Christmas edition of this presentation. There are 5 sections for the course I watched. The first one's about callback functions, and we're going to start off with a little Christmas tree example. So, in this example code here, if we start at the bottom, we are console logging 2 constants, one called uppercase and one called lowercase. This one logs out Christmas tree, all caps. This one logs out Christmas tree, all lowercase. And they both get passed into this copy and manipulate function, which we'll take a look at up here. But it's important to notice the 2 arguments being passed in. We've got this multiple caps Christmas tree, and then we're also passing in a secondary function, either capitalize or decapitalize, which I made up. I don't think that's an actual word. And then what would happen when we call copy and manipulate, it passes the string in, it passes in this second function, and it does that to each character. So that was just helpful for me because I think I had a vague sense of what a callback function was. I'm not sure if this is a thing that applies to other languages other than JavaScript, but it's really important for the next topic I'm going to talk about. So, a callback function is a function that you pass into another higher order function, which in this case is copy and manipulate. Closures is a really cool topic that kind of explains how React Hook works, and it involves callback functions. So, the way that Will talked about it in the video was it's like a backpack. So we're going to look at a Santa example, and this is actually pretty close to what React Hooks looks like. So if we start on line 91, this is what you would set up for React Hook. You've got the name of your variable that you want to save the state of. We're going to call it Santa name. You've got the name of a function to set that state, so set Santa name. And then you have this React Hook generic function called useState. We pass in an argument to useState called Santa Claus, so that sets our initial value to this hidden value variable. And when we call state, which remember is Santa name, we are going to get this value back. So on line 93, if we console log Santa name, then we're going to get Santa Claus printed out. Likewise, if we update the state of this variable, so we set Santa name to this new value, Kris Kringle, then it calls this set state function inside of useState. It sets the new val to this hidden value, and then when we call state again, which we do on line 95, we return this new value, which has been updated here. So Kris Kringle prints out, and basically this concept of closures lets us have React Hooks lets us have persistent data within a function, which is pretty cool. That's the closure. The third section was about asynchronicity in JavaScript, and one of the coolest parts I thought was about facade functions. So basically, it's this idea that the browser actually does a lot of shit for us. Like, I thought this was all baked into JavaScript, but it turns out it's the browser doing all of those, and they're just named something different. So we're going to look at some presents. In JavaScript, you call something like we've seen in the previous 2 examples, console log. And that is actually calling something in the browser called console, which is, these are browser APIs. We use something called fetch in JavaScript, and that actually is just a facade for these network requests. It used to be called XHR. Document is another item, like a variable name that we use, and it represents the HTML document object model, which we call the DOM. And then set timeout is another popular one, which calls this timer API. So I thought that was cool because I didn't actually realize that there was this separation of what JavaScript actually does versus what the browser actually does. And that's kind of cool. Promises was the 4th section. So we're going to look at the 3 wise men. And this also has a little bit to do with how the asynchronicity in JavaScript works and how the event loop works. But we're going to come down here to line 160. We're going to run this function called gold. And what prints out is gold, frankincense, should be right after frankincense before myrrh, and then finally myrrh. And so when we jump into gold, we console log gold first, no problems. Because we call set timeout on line 153, even though we hit it next because it's synchronous, it actually throws it into I can't remember exactly, maybe the call stack. It throws it into a list to come back to. Then on line 154, we kick off a promise, which also throws it into a list. And then we print out frankincense, or we hit this function frankincense, which we invoke, and we call it, and it console outs frankincense. So now we've got 161 and 162, and then the promise actually resolves next, and it takes whatever amount of time it takes to resolve, and then it console logs what it resolves. Oh shoot! No, it console logs what it resolves, which is this line on 155. And we see that printed out on 163. And then finally, once all the stuff that's in the normal stack is complete, then it goes back to the set timeout, which it put in this like task queue. And we call this mir function. Even though it said to do it after 0 seconds, it just got like deprioritized, and we console log mir out last. So in the final example, we are going to talk a little bit about classes and object-oriented programming in JavaScript, which is kind of new as of 2015. And also, I'm not sure that it's super ubiquitous or is going to be, but I still think it's interesting to talk about because we have an example of a use case. So let's look at some Snowman. In this example, on line 208, we create a snowman. We use this keyword new, and we call our snowman creator class, which is defined up here. We call it with the caret as the first argument, and the string caret, and then the Boolean true. In this constructor, which is where we pass those arguments, the first parameter is nose, so what's it made out of, and then has scarf. So for this snowman, has scarf is true and it has a caret nose. And on line 210, when we call snowman take off scarf, it changes this has scarf to false. So the result is that the snowman has caret nose and no scarf. And the example I think we're going to use this for in our React code is this the program class. It would be really helpful for us to have a one source of truth place to define a program, not unlike maybe the program config that y'all have created on the back end. So we are going to start working on that refactoring. I know we've been talking about it for a while, but there's a lot of prerequisite work to do it. So that is my presentation. Hope you enjoyed.